solve these three other problems on your own. So to recap, because my recording just crashed as well, and I think that's probably going to be gone, we are reviewing our exponent work from Tuesday, and we brushed up on the fact that when we use multiplication with exponents, we actually add our exponents, because 2 to the third is 3 2s, 2 to the fourth is 4 2s, and we end up with 7 2s. So likewise with division, what we said is we're actually going to subtract. I'm going to random call on people to give me answers for these. If you want to challenge, that bottom one is kind of like our challenge problem, and then I need to actually send attendance and hope everything doesn't crash again. Do we have Colin Chase? Am I just missing you? That's good to know. Thank you. Like I'm about to go to the dentist. So that is another reason why I like to try to record my class, is then if I know that kids missed, I don't always remember to do this, but if kids email me and say, hey, I missed class, what did I miss? I can just send the video and say, here's what you missed. It's way efficient, but I think I need a bit more power in my computer. And anyone who knows computers, I need more RAM. I need to put more RAM in my laptop, I realize now. Do we have Hannah? Am I just missing you? Are you here? Yeah, you're here. I see you now. It's fashion.
I have 8 gigabytes of RAM on my PC.
Yeah, let's show off about it.
I got 16. That's 8 gigabytes is not good. It's a gaming PC.
Whoa, hey, quit throwing shade, people. 8 gigabytes is probably perfectly fine for the machine they're running. You guys so quickly want to like weird flex on each other. Like, oh, you're 8 gigs, I got 45! And that's not even a measurement that it would be in, because it's all divisible by even numbers. I love hard drive spaces, like 1024 gigabytes. Like, why isn't it just 1,000? But 1,020, because it starts at 512 and below that, right? All right, sorry, I need to finish attendance. Maya, yes. Rachel, yes. Shia, yup. Kelly, yup. AJ, yup. Ben. All right, we're all here except for a legitimate reason, because an eye appointment is important. Guys, if you have not been to the optometrist or the dentist in like a long time because of the pandemic, you should tell your parents, like, hey, I should probably go, right? Because you're in middle school and your body's changing a bunch. You need to go to the eye doctor and the dentist. It's important.
I went to the eye doctor and then I found out I needed glasses, so I'm kind of against it now. I don't want glasses.
Would you like to be able to see?
But I can see just fine.
Hey, Logan, when it's time to go get your license, do you want to fail a licensing test because you can't see well enough? No.
It's positive 75.
Okay, I don't know what that means. All right, Logan, thank you for volunteering. 4 to the third divided by 4 to the second. What would this be? No, you volunteered.
What? No.
Did you not solve these while we sat here solving these?
I tried solving them.
No, you didn't.
Yes, I did.
Logan, you now painted a target on you that when I give you guys time to solve problems, I need to check on you and make sure that you're actually solving problems. Hey, just to say it, sorry, because I'm recording, don't raise your Zoom hand because then it pops a notification into the Zoom thing. Just raise your actual hand. Ivan, what will this turn into?
4.
4 to the what power?
First power.
Yeah, and do we need to write a first power? No, so that's why Ivan just tried to tell me just 4, because when a number's to the first power, we don't actually have to show the first power. So this one would just turn into 4. But guys, this is not 0 power, right? This is what a lot of people get confused on. A number by itself has a first power. It has a power of 1. Akshaya, what's this become? 4 to the what power? Sorry, I couldn't hear you. 4 to the 5th. Dewan, stepping down to the next row of my students here in class. Dewan, what's this become?
I'm gonna be 100% honest with you. I don't know.
So let's work through it together then. We said that just like multiplication, but kind of the reverse of it. So actually, we might want to write this down. This might be because we didn't write this down. So we should say when, so that's an E, when dividing, we subtract the powers. So, like I showed up here, the reason this happens is 6 to the 5th is 5 6s being multiplied. 6 to the 2nd would be 2 6s multiplied, and things reduce out to 1. That's why we subtract, is what we end up left with is everything that didn't reduce out to 1. So, Dewan, if you had 5 y's, not 5 times y, but 5 y's on top and 3 y's on bottom, how many y's from the top don't cancel out with y's on the bottom? Yeah. So we end up with y to the 2, or y to the 2nd power. We can also think of it as y to the, what we did was 5 minus 3, right? We did the subtraction of numerator minus denominator. Now in Khan Academy, you're going to see problems like this, where then they throw in a variable in one of the parts. So I just wanted to go over like how to think through this. Sorry, I see people with hands up, but I got to keep kind of working around the room and calling on different people. So even if you have your hand up, I may not call on you. Sebastian, can you explain to us what's going on here? Yeah, that's how we say it, 4 to the 0th power.
So we have to figure out what x we need to get 0 to 6 minus 6
Yeah, so Sebastian's saying, I know I have to subtract to get to my new value, and what should be taken away from 6 to get to 0 is a 6. Now, the reason that I chose this problem is x is 6, saying that this power would be 6. But I wanted to take a moment and talk about what does 4 to the 0th power really mean. It means however many 4s we had on top, we had an equal amount of 4s on bottom. So like 4 to the 3rd minus 4 to the 3rd, I'm just not going to write out 6 of them because that would be a lot. We cancel, right? Or we reduce out to 1. So this becomes 1, this becomes 1, this becomes 1. So what is the answer, Ben, to 4 to the 0? What does this reduce out to? A number to the 0 power would reduce to... If you need help, I will help you with it. I'll admit I called on you because you looked like you were off task.
Yes, sir, my brother asked me a question.
It's all good, especially if you're helping AJ get caught up. I know we were out of class a little bit.
No, my little brother.
Oh, different brother. So, if this reduced to 1, this reduced to 1, and this reduced to 1, what is 1 times 1 times 1? Yeah, I got a couple people holding up fingers. And that could be dangerous, but I have people holding up that, right? So 1. You got to choose which finger you hold up strategically. A certain one is not good, right? There's a certain finger we want to avoid. Yeah, absolutely. Sorry, there was a little lag there. I think it took a little bit of time for your audio to come across to mine. But any number, guys, you can make a little note here. Any number to the 0 power is always going to be 1. Because it means we have an equal amount of those numbers in the numerator and the denominator. Now, separate from a 0 power problem, I'm trying to decide what color I should use. I think my next page goes in this color. So we had like y to the 5th over y to the 3rd. What if we had y to the 3rd over y to the 5th? Uh-oh. Uh-oh. Sebastian, I love it. You're on the screen, you're backwards though, just because how the screen flips. Everyone think about this for a moment. If we're subtracting, if this tells us we're supposed to subtract, or what we just talked about is this is y times y times y. This is y times y times y times y times y. You guys can put your hands down if you're holding up an answer. This is something I need to take a moment and teach us. Everyone who held me up an answer, I believe, is right. Y over y reduces to 1. Y over y reduces to 1. Y over y reduces to 1. And I have two y's left on bottom. So this becomes 1 over y squared. But a lot of you are holding up y to the negative 2, which is correct and is the next thing we're going to talk about. It is actually my next page of notes. Sorry, you shouldn't be able to see that 1/3 yet. So this whole page was leading us to the next page, but does anyone have any questions on the fact that when we have a division problem with matching bases, guys, I cannot emphasize this enough, matching bases. So 6 and 6 are our base, 4 and 4 are our bases, 3 and 2 are our powers. 4 is our bases, 8 and 3 are our powers. Y is our bases, or here 4 is our bases, Y is our bases. Bases have to match. We subtract the powers. Any questions on this page? All right, now I commit to you, my goal is to be done with class by 2:15 so that I can pack up and get to my dentist on time and, brush my teeth before I go, because you should probably just brush your teeth before you go to the dentist. So, moving on, I don't love that I started this page with the word because, but you're probably not starting a new page. You're probably continuing, but even if you're starting a new page, that's fine. Because exponents can be used to show multiplication, it would make sense that they can also show, what's the inverse of multiplication? Yeah, division. Wait a minute. Nope. Good guess, though. That's a really good guess. So here's the deal. Positive exponents get used to show repeated multiplication, right? So if we had, I'm going to use all my apartments.com post-its. I have a friend who works for apartments.com. I don't know if I've said this before, but that's why I have freebies from apartments.com. So my friend works for them. Guys, if you had like 5x to the 3rd, we know that what that means is 5 times x times x times x, right? Because this is 5 times x, and then x to the 3rd means there are 3 x's. But just like a positive power gets used to show repeated multiplication, the question becomes, what if this was 5x to the negative 3rd? Well, how does a negative number relate to a positive number? They're inverses, right? They're opposites. What's the opposite of multiplication? Division. Thank you. So we show division by using negative exponents. And we can abbreviate exponents with EXP if you want. So what 2 to the negative 3rd actually means is we're dividing by 2 times 2 times 2. And there's always a 1 times, right? So if we quote unquote don't know what's in the numerator, guys, there's always a 1. Now, here's the trick a lot of parents and siblings might tell you. 2 to the negative 3rd might be written as 2 to the negative third over 1, just to put it into fraction form. And what people will tell you is the negative exponent, and this works, it is true. The negative exponent tells you to flip that to the other part of the fraction. So if you have like an older sibling or a parent that tries to help you with this, they'll say, oh, the negative tells you flip it to the other part, and then that's how you get rid of the negative. That does work, and the reason that we use that like trick is in case we have a negative exponent in the denominator, it'll flip up to the numerator, but we're not doing problems that hard yet. Rachel, what's up?
Can you slow down a little bit?
Yes, absolutely. I know this is a lot to take in. So, let's say I bought a pizza and I want to cut it in half, and cut it in half. Like, first I take my circle and I cut it in half, then I cut those halves in half, and then I cut each of those pieces in halves again. What really happens when I cut that pizza in half, in half, in half? You know what happens when you cut a pizza in half, in half, in half? How many slices do you end up with? 8. This becomes 1 over 8 because 2 to the third is actually 8. 2 times 2 times 2 is 8. So when we're asked to simplify 2 to the negative third, it becomes 1 over 2 to the third because the negative is actually telling us, well, that should be in the denominator. That should be division. And then, well, 2 to the third is 8. Now, sometimes we do have a number multiplied or an exponent multiplied before the thing that's raised to the variable. So a big announcement that I wanted to make as like a reminder is the variable only applies to the thing it's attached to unless there are parentheses involved. So if we see situations like this is different. Don't write this down yet. This is different. But if we don't have parentheses involved, this negative 3 power only applies to the 2. So if the 4, if we were trying to make it into a fraction, 4 is 4 over 1, right? So the 4 is in the numerator, but what we just said with 2 to the negative third is that tells us to put it in the denominator. So I'm going to write in a pen for a moment just to get some space back on my paper. This 4 is going to go in the numerator. 2 to the negative third, to get rid of that negative, we flip where it is. So it was up in the numerator, quote unquote, right? It was just up here in the numerator, quote unquote. So we apply the negative and it flips it into the denominator. So the negative's gone now. And now we do what we're able to do. 2 to the third, we can do that. 2 to the third is 8. Well, what is 4/8 when we simplify it? Yeah, this is actually a complicated way of getting to 1/2. Another way to think about this is 4 actually had a power of positive 1, right? We said everything always has an assumed power of positive 1. Positive powers stay up in the numerator. So 4 to the first, 4 to the first, and then we reduced it out. Rachel, was that enough time to get caught up, or do you have any questions at this moment?
I'm all caught up.
Awesome. Hey, Nick.
Yes.
Just checking to make sure that you're here. Happy to have you in class, dude. So Nick and I have a standing agreement. He doesn't have to have his camera on because he's got internet issues that we're working through, and the best way for him to hear me is to have his camera off. And none of this will matter once we come back to school hybrid, but that's why I just randomly, checked on Nick. Anyone have questions at this point? This is new. I know it's complicated. Let's do a couple more and see if you... Actually, do you guys want to see another one or you want to try it on your own? First person to unmute and tell me.
See another one.
Ooh, I got both answers at like the same time. All right, ignore my screen if you don't want to see it. I won't talk it through. I'll just write it through. Okay, so look on your own paper. Actually, everyone copy these down real quick. Just take a moment and copy this stuff down. Before we work it, just copy it down. I'll give you a moment. And then you can start doing it on your own if you want. If you want to wait for me, you can wait for me, I guess. That is a Z. I know my Z's and my 2's look similar. I use Z because 2 to the 7th we could figure out, but it'd be really big. So I just decided to use Z. And sometimes we use variables, sometimes we use numbers. We go back and forth. Too high. Anyone want to volunteer to take a risk and tell me what this first one turns into? Akshaya?
X over 3 to the 5th.
X on top over 3 to the 5th on bottom. And then we could do 3 to the 5th if we really wanted. 3 times 3 is 9, times 3 is 27, times 3, ooh, this is getting tough. 27 times 3?
71.
Okay, yeah, I don't know. I have to trust you. 71 or 81?
81.
81, okay. 81 times 3, one more 3.
243.
Ooh, 243. I won't take us much higher than that. 6 to the 5th, that's a really big number. We don't even have to do, we can use a calculator to do that. Anyone want to tell me what this one becomes? B to the negative 3rd. Audrey, I can't stop looking at your amazing headband. Do you have a guess of what B to the negative 3rd looks or turns into? This one's tough. I know this one's tough. Yeah. It helps if we put a 1 in front and say 1 times b to the negative 3rd. Adam, what do you think? You're slowly spinning. You look a little bored. I'm hoping you might be able to give me this.
Shot in the dark. 1 over b to the 3rd.
Shot in the dark gets your target. 1 over b to the 3rd. Absolutely. The 1 stays in the numerator. B to the negative 3rd says we'll go down to the denominator. We're actually dividing by b. If you wanted to expand this, it's 1 over b times b times b. But we normally don't need to expand things. We normally compress them. Anybody, y to the negative 2? Just unmute, shout it out. 1 over y squared. And guys, we really only get better at this through practice. So just going into Khan Academy and practicing is how you'll get better at this. Right now, you can't honestly answer me if you are mastered or not. You haven't practiced enough. So even if you're feeling comfortable right now, you might be like, oh, I think I'm mastered on this. I get that idea. You gotta practice. That's why there were so many homework assignments this week. They're all related to each other. None of them are like crazy different topics. They all build on each other. So going the other direction, If you start 1 over 6 to the 5th and you're asked to write it using negative exponents. If we're asked to write it using negative exponents. Kelly, do you got a guess on what this is going to turn into?
Yes.
Maya?
Isn't it 1 times 6 to negative 5?
Yeah, because if we want to pull it out of the denominator, that power becomes negative, and we don't need this 1 times, so we could just say 6 to the negative 5th. If we wanted to write this one using negative exponents, Sophia?
Z to the negative 7.
Yeah, z to the negative 7th. Uh-oh, this one's tough. Anybody unmute and jump in. What's this turn into?
Negative 3 to the 1st.
Wait, negative 3 to the 1st? I think you got your words in the wrong order. It's 3 to the negative 1st. So, but I like whoever said that. This brings up the point. It doesn't matter if the base is positive or negative. What we're talking about here is the power. So, let's say the base was like a negative 5 to the negative 2nd. What that tells us to do is take the entire base, the entire negative 5, and divide by it twice. So this would turn into 1 over negative 5 squared. So, which would really turn into 1 over 25 because it would turn positive when it squares. But yeah, be careful. The negative in the power doesn't do anything to the actual number. It just tells us to divide. It does not make our number negative or positive or anything like that. So now, what would then happen, because I'm trying to wrap this up in the next couple minutes, and these are the last 3 problems we're doing today, if we had multiple things being raised to the power? And this actually isn't that crazy of an extension from what we've already been doing. I think we talked at least once this year about the distributive property. We essentially distribute the power. I've got the power. If you guys don't know the song I'm talking about, you just think I'm a weirdo right now, which is fine. Most math teachers are kind of weird. So we distribute the power. Now we got to be really careful here though. This is not a power times a power, it's a power to a power. What do we do when we have a power like this second power to the third power? What do we do with the powers? Multiply them. So this becomes 3 to the 6th times 5 to the 3rd. Yeah. And our second one here, we distribute the power to both the top and the bottom. So this becomes 5 to the 8th over 4 to the 4th. Now this is going a little bit further than you necessarily have to right now. If we were asked to write this not in a fraction, this would turn into 5 to the 8th times what?
4 to the negative 4.
Yeah, pretty soon I'm going to have to start paying Akshaya if you keep letting her just run the class. I'll have to send you Bitcoin or something. Well, you'll be back in school next week. And then our...
Bitcoin?
No, I'm just making jokes. There was like a moment in time where if you bought Bitcoin and waited and sold when it was really expensive, you could have made money. But now it's just kind of like a joke. Bitcoin is essentially a joke.
They're worth.
So here's the big thing I'm trying to encourage you guys here. X and Y, even though they're both variables, they're not the same variable. We cannot combine them. And it doesn't matter that they have the same powers. Aside from that, we could write this in another way, but we cannot combine these. So we can say x to the 12th. Actually, you sound so excited. And y to the 12th. Now, we could rewrite that as xy to the 12th if we wanted to, or we could just keep it split x to the 12th times y to the 12th. With that, guys, that is everything that I had planned for today. And like I said, I have a dentist appointment that I have to get out to. So if anybody has any questions, I would love to take your questions really quick. Aside from that, I'm probably going to go ahead and say, oh, thanks, Nick. 6 to the 5th power is 7,776. I'm guessing you used a calculator. I already put that in my binder. Okay, so here's the deal. We didn't need to solve that unless we just wanted to solve what this was. We actually wanted to convert this into using the negative power. So that's why we didn't actually care to look at what it really was. I'm impressed that you did not use a calculator. Nick said he put in the chat that he did not use a calculator to do that. But, Nick, this is what we were practicing, is converting up into using the negative. All right, so you guys are welcome to leave. Unless you have a question, and if you have a question, just unmute and throw it at me, because I'm going to start packing up my backpack. Thank you guys very much for coming. I would go work on math right now if I was you. But we're going to take our first mastery next week, by the way, when you guys are back at school. So be ready to take a mastery on what we've done so far. Bye, guys. Have a great day. Wish me luck and no cavities. Wish me no cavities.
You said that all math teachers were weird. Have you ever?
I didn't say all. I said most.